In this video, we are going to solve some problems on charges and electrostatic force. So the first problem is on quantization of charge. A strong lightning bolt transfers about 25 coulombs to Earth. So that's the value for Q. How many electrons? That means they want us to find what's N. How many? What's the number of electrons? So that's N. So we have the formula Q equal NE, where E is a constant which will be given in the exam. It's elementary charge, 1.6 times 10 to the power negative 19 coulomb. So we can substitute these numbers into the formula and divide both the sides by 1.6 times 10 to the power negative 19. If you want, you can use shift solve in the calculator, putting n as x on the calculator and solve. Here I'm just rearranging the equation, and then I will get the answer as 1.56 times 10 to the power 20 for the number of electrons, that is n. There is no unit for n because it's the number of electrons. Next question is on electrostatic force. 3-point charges lie along a straight line where Q1 is 8 microcoulomb, Q2 is 2 microcoulomb, Q3 is negative 4 microcoulomb. The charges are separated and the distances are given in the diagram. The first part is asking calculate the magnitude and direction of the electric force exerted by Q1 on Q2. So Q1 on Q2. So we should focus on Q2 because we want to find the force on Q2. So I have highlighted that in the diagram. Now Q1 and Q2 both are positive charges. That means also the question is asking you to get magnitude and direction. So as I said, Q1 and Q2 both are positive charges. There will be force of repulsion. So Q2 will be pushed to the right. So Q2 will have a force because of Q1 to the right. We will write that as force of 1 on 2. Again, our focus charge is 2, so we are drawing forces only for Q2. So the direction of the force, you can see it's to the right. Now to find the magnitude, you will use the formula K Q1 Q2 over R square, substitute the numbers, remembering to convert micro means 10 to the power negative 6, and then put the numbers into the calculator. You get the answer as 160 Newton, and the direction will be to the right. The question is specifically asking magnitude and direction, so you have to write magnitude 160 Newton and the direction is right. The next question is asking you find the magnitude and direction of the electric force exerted by charge Q3 on Q2. So again our focus is on Q2, but this time we want to find what's the force of Q3 on Q2. So if you look at the diagram, Q3 is negative and Q2 is positive. That means there will be a force of attraction, which is shown by the purple arrow. So that's the force on Q2 by Q3, because Q3 is trying to pull Q2 to the right. That will be the force of 3 on 2. So we again apply the formula, put the numbers, and we'll put the charge as positive. You can see that it's negative 4 microcoulomb, but I am putting it as positive 4 microcoulomb. 4 times 10 to the power negative 6. In the formula, we'll put it as positive because we are doing magnitude and direction separately. Let's put the number, put it in the calculator. You get it as 180 Newton, and the direction is to the right as shown in the diagram and as we discussed before. The next question is asking you before that, let's label the forces as F12 and F32 to know that which force we are talking about. So there are two forces acting on the charge 2. Next question is asking you find the net electric force on Q2, F net. So there are two forces acting on Q2 and both the forces are to the right. That means we are going to add the forces. So check the direction of forces for calculating F net. Both forces are to the right, so we'll add the forces and we get the answer as 340 Newton, and the direction of the net force is also to the right. Okay, let's do one more problem on electrostatic force. A balloon rubbed with a sweater gains a charge of negative 6 microcoulomb while the sweater lost the same amount of charge. So Q1 on balloon is negative 6 microcoulomb. Let's convert that to get that into coulomb. Micro is 10 to the power negative 6. Now sweater lost the same amount of charge. That means Sweater's charge will also be exactly same, but it will be positive because it lost electrons. Okay, and then we convert that micro to write it as 10⁻⁶. What is the magnitude of electric force between balloon and the sweater when a distance of 10 centimeters separates their center of charges? So the distance is 10 centimeter. We convert centimeter to meter. We get that as 0.1 meter. So that's important to note the units. It should be in meter. We use the formula and we put the numbers, get the answer as, okay, before getting the answer, I want to again emphasize that both the charges will be put as positive in the formula because anyways the question is asking for magnitude. We can see that Q2 was positive but Q1 was negative, but in the formula I am putting it as positive so that we can get the magnitude of the force, which is 32.4 Newton.